Hello, algebra students. Well, today we're looking at section 6.7, Rational Exponents, Day 2, and we'll be looking at operations using rational exponents. And we will, when we're finished doing the exponent operations, you will have to work with the radicals. And so it continues to keep you in practice working with the radicals, which will help with the test. Okay, that's the test that's coming up on chapter 6, part 1. So here's a review. I'm looking at whole number exponents. Okay, and these are things that we're familiar with already. When we multiply here, we add the exponents, right? When you raise a variable that's raised to an exponent to a power, okay, you raise it, it already has an exponent, and then you raise it to a power, you multiply those exponents, right? 2 times 4 in this case is 8. When you're dividing, you subtract exponents. Okay, and when you have the negative exponent, you flip it, and it becomes positive in the denominator. So all of those same operations will be done with rational exponents, that is, exponents that are fractions. But then after you finish all of that exponent arithmetic, we're talking about this right here, when you finish all that exponent arithmetic and that's all done, then you'll put it in radical form if necessary to finish simplifying. Okay, so we will see how that works out. So here's some examples. Simplify completely. So here we have one that's raised to a power. Okay, it's 3 to the second power, and that's raised to the power of 3/2. So you multiply those exponents, right? So let's just look at that multiplication problem. The 2 is 2 over 1. And you multiply that by 3 over 2. That's the outer exponent. We multiply numerator times numerator. You get 6. Denominator times denominator. You get 2. And that is 3. So that's the result of the multiplication of exponents. So we have 3 to the third power. Okay, we multiply those, and that gives us the exponent. So this time there's no denominator on that exponent. It's not a fraction, so we're not going to have to use radicals for this one. We simply raise 3 to the third power. That's 3 times 3 times 3. That is 27. Okay, look at the next one. Dividing. So, dividing, we will subtract exponents, right? So, this time they are fractions. We have to subtract fractions. Not too bad. So we have 3/4 minus 1/2. What is that? Well, we will change 1/2 to have the same denominator, right, as the 3/4. You have to get the common denominator before you can subtract. So we could actually rewrite it like this, leaving 3/4, the exponent on the numerator, 16. And then let's go ahead and write down 1/2 as the exponent in the denominator. We're just going to write this again, but this time we're going to get the common denominator. So 1/2 is 2/4, right? So we will write it as 2/4. It is the same thing, But now we have a common denominator with the 3/4 and the 2/4. We can subtract them. 3/4 minus 2/4 is 1/4. And so that is the exponent on 16 when we're done. So now we just have to take the 4th root of 16. Now, we could also see this numerator. That's our exponent, right? So I said the 4th root of 16. It's actually the 4th root of 16 to the 1st power. Of course, that is 16, right? So the numerators of the exponent, the numerator of that rational exponent is 1. It goes here, like we said. The denominator of 4 goes here. And now we just take that 4th root of 16. Remembering, of course, that the 1 here, you don't have to actually write it. It's still just 16. 4th root of 16, we can take that, and you may know this one by now. We've used it quite a bit. 4. Okay, so groups of 4 is what we need because the index is 4, right? And there's one group of 4. One group of 4 twos, nothing left over. So we just pull it out, and that's the answer. Okay. Look at the next one. Okay, so we're multiplying, so we add exponents here. Okay, but then once we get those, we will multiply exponents because we have the exponent out there. So let's do that. Add exponents first. They have the same denominator this time, right? 1/4 each of them, but 1/4 plus 1/4 is a half. So that becomes our denominator there. We are raising that to the 8th power. So we take 1/2 times 8 gives us 4. We have 3 to the 4th power. We calculate that, we get 81. Okay. Just a couple more. 27 to the negative 2/3 power. Okay, so we do have to flip this one, right? So that becomes 1 over 27 to the 2/3 power. Okay. Now, that's all the simplification that we can do with the exponent. So, we're ready to write it in radical form. Now, this is one of those where we have the 27, we have the base raised to a rational power. We're done doing all the arithmetic we can do on that exponent, and now that's when you put it in radical form and finish simplifying it. Okay, so the denominator is 3, the numerator is 2. The numerator is our exponent on 27, 2. And that denominator is the index of the root, and that's 3. And now we've got to see what that is. It's a little hard to see that too. Okay. 2 is the exponent. There we go. 3 is the index. Now remember, you take the root first. So we take that third root first, right? And that looks a little funny because you feel like you should do it from the inside out. This says the third root of 27 squared. You should square 27. And you should, but you get the same thing both ways, okay? So it really is the same thing. So we take the third root first, and then we're going to square that. I've got everything a little bit crowded here. It's a little hard to make my circle. There we go. Okay, so what is the cube root, we could say, or the third root of 27? We can cake it to find out. And we're looking for groups of 3 because the index is 3. There is a group of 3, and so that cube root is 3. Now, actually I need to put it down here, right? 1 over 3, because we did that cube root, but now we need to square that. 1 over 3 squared, and that's 1/9. Okay. One more. We have 8x to the 9th to the 1/3 power. Okay. So we have some exponent arithmetic to do here. Multiply, right? The 1/3 is applied to each thing in there. So for 8, its exponent, of course, is currently just 1. So 1/3 times 1 is just 1/3. So we get a 1/3 exponent on 8. And then we have x to the 3rd power. That's 1/3 times 9, okay, is 3. So that part's done. We can't simplify it. But this 8 to the 1/3, we have to figure out what that is. Well, 8 to the 1/3, we could put the exponent here on the 8. And the 3, of course, is the index. That's 8 to the 1/3. So we have the third root of 8, the cube root of 8. And we know that is 2. Okay, we could cake it to show that. Whoops. And so look for groups of 3. We have them, and yes, it is 2. 2 comes out of the radical. Whoops. So that is the answer. Okay, actually get rid of that arrow. There we go. Okay, so I think that's our last example. Check my notes here. Yep, that's it. So after doing all the exponent arithmetic, you just go ahead and change it to radical form and then simplify it the rest of the way.